Okay, so in this video, we are going to find the curl of a vector field. So what's up with the curl? Okay, so curl of a vector field is defined as the cross product of the del operator, which should be like, what the heck is that? Well, that's the partial derivative. So it's a vector of partial derivatives of what? Of nothing, just partial derivatives. And then you cross it with the actual vector field. So this is a cross product. You think it's a cross product, but it's just a notation. Okay, just to remember how to find it. So the way we find the cross product is the first row should be ijk, if you remember, right? The second row is going to be those partial derivatives. So it's that del operator. So it's really not a vector per se. It's just contains partial derivatives that are going to be applied to the components of our vector field. And the vector field is PQR, let's say. So how do you do it? Well, what you do is you take the ith component, right? You're going to cross it out, right? This. And then you're going to take this and multiply. Well, what does it mean multiply? How can I multiply? You're not really multiplying. You are applying the derivative with respect to y to r. So this is going to be partial of r with respect to y minus the other one. So this would be a partial of q with respect to z. Okay, so that's going to be your ith component minus. Remember that the jth component has to come with a minus. Okay, so just remember that ith plus, j minus, k plus. Okay, so now we're going to cross out this row, this column. And again, we're going to apply the partial. So apply the partial with respect to x to r minus partial with respect to z to p. Finally, the kth component. Now, you do not need to memorize this. Hopefully, you remember how to find the determinant. If you do, then you don't have to memorize it and write it out. Like I'm writing it out just for whatever. Okay, so then let's cross out the k. And then we're going to get like this one, right, first. So this is going to be q with respect to x, subtract derivative of p with respect to y. Okay, so whatever. Please do not try to memorize it. Just remember how to find the cross product, and that's all you need for the curl. Okay, so I is in the numerator. First row, I, j, and k. Then we got those partial things, which is the del operator. And then we got the actual components. So 4xy, 6 minus z to the 8y. And then we have x to the 7 plus y squared. So it's a lot of partial derivatives to take, basically. So first the ith component. So what happens to that? Okay, so we're going to take the partial of this guy with respect to y. Okay, x to the 7 is 0 with respect to y because it's just a number. Y squared is 2y minus the other ones. Okay, here we have to be very careful. The 6 becomes a 0. Okay, then minus, okay, so z to the 8 derivative is 8z to the 7, and the y still stays because it's a constant. Okay, so these two minus will actually become a plus. Should have left myself more space there, but okay. Next one is the j. Let me leave more space. Okay, so for the j, we are crossing out here, here. Okay, so that means we're taking the derivative with respect to x of this again, but this time it's with respect to x, so that's going to be 7x to the 6 plus y squared goes away, minus, now this guy with respect to z, oh, that doesn't have a z, so that's 0, okay. Then the kth component, finally the k, so got to that. So let's cross out this row, this column, and we are taking the derivative of this guy with respect to x first, but it doesn't have an x, so that's 0. Minus, then it's going to be this with respect to y. Well, that would be 4x, right? Because it's like number y, it's a number. Okay, so let's see if we can put that in there. So the ith component, it says vector, so we're supposed to put it in a vector format, not ijk's. Okay, so 2y plus 8z to the 7y. Okay, y plus because there's a minus minus, right? Then the j comes with the minus, so that's actually going to stay negative. And then minus 4x for the kth component.